Welcome to a lesson with Dr. Powell. Let's take a look at solving an equation. We have x plus 1 minus square root of quantity x plus 7 is equal to 0. All right, we want to find the values of x that would actually satisfy this computationally and make a 0 on this side if we plugged it in over here. Now to do that, it'd be nice if we could get rid of the square root. How do you get rid of a square root? You got to isolate it so it's alone, so that when we square it, it goes away. And we're going to do this thinking about inverses, inverse operations, inverse functions, if you will. Now, if we add this to the other side, we're going to get square root of x plus 7. That's going to be equal to x plus 1. Now, the problem with squaring both sides is we might get some extra stuff, some extra values of x that won't really quite work. And it has to do with what we're really doing. You see this square root function? In fact, I'm just going to think about the whole inside as being just x for a minute here. Think about f of x equals square root of x. If we undo it, we're actually using its inverse function. Its inverse function, think about square root of x. It looks like this, or goes off that way. And if we swap our x's and y's, it looks like this. It's actually equal to x squared comma x is greater than or equal to 0. There's a restriction into what we're squaring. In particular, if we square both sides, what are we plugging into the square? We're plugging x plus 1 into the square, and the output of square root of x plus 7 into the square. The output of just a positive square root is actually positive always. No problem there. But the output of this, we have to be careful. We want the output of this to be strictly positive if we're going to be undoing things exactly and not adding in any extra solutions. Because really what we're doing, if we square both sides, we're changing the domain of the equation. There's no restriction. Before, there is a restriction right here because we don't want what's below this to be negative. Get rid of that. We've kind of messed things up a little bit, and we could run into some issues. Okay, but maybe that's not all, because maybe that's not the problem. It is possible that we could just get more solutions because our inverse process wasn't really quite inverse. It did more. So what we're going to do when we square both sides, we're going to have a restriction. We're going to assume that x plus 1 itself has to be greater than or equal to 0 because that's what we're plugging in when we're squaring. Whatever we're squaring needs to be greater than or equal to 0. So that's our restriction right away. We square both sides now based upon that restriction. And then what happens? We get x plus 7 is equal to, square that guy out, x squared plus 2x plus 1, subtract off x, plus x, subtract off 7 minus 6, and this is actually factorable. Get x, 2, 3 with a minus and a plus. So when this is 0 or that is 0. So when x is 2 or x is negative 3. But notice, we had an assumption, which right here means that x must be greater than or equal to negative 1. Outlawed right there. X is 2, we'll satisfy it. We plug 2 in just to verify. We get 2 plus 1 is 3 minus the square root of quantity 2 plus 7, square root of 9. 3 works. But notice if you put negative 3 in, it wouldn't work. Negative 3 right here, but even though negative 3 is actually in the original domain. Isn't that interesting? It's in the original domain, but it didn't quite work because this squaring process that we're using, we have to use this restriction. If we put the negative 3 in, you're going to get a negative 3 plus 7, which is 4. Square root of 4 is 2, okay? So you're going to get 2, so we could take a square root. That was nice. But then if we put negative 3 over here, what would you get? You get negative 2 minus 2. Oh, my goodness. That's not 0. So, and it did not work. All right, so moral of the story. If you don't want to think about restrictions like this with your inverse processes, you need to check your solutions at the end back into the original, especially if you're using an operation which is more than invertible. A squaring operation doesn't really, if you swap your x's and y's, it's not a function. And if you ever run into something like that, you got to be careful. And But if you ever do an operation anyway that just changes the domain, it's a good idea to check back anyhow, just because your domain has changed around when you get rid of domain restrictions. Even though that wasn't an issue in this particular one, our issue was in particular that we're just doing more than simply inverting. Thanks for watching.